Hi, my name is Matt Anderson, and I'm here to talk about Deaerators. So I have about 5 years experience in refining in engineering and operations. I am a PE with my license in California, and I'm definitely not an expert on Deaerators, but I know the basics and something I want to talk about today. Alright, so here's my block flow diagram. Boiler feed water going into Deaerator with boiler feed water out. That should look confusing, should look like it's pointless because we're missing some details. So the main detail there is about dissolved oxygen, which is called DO, and then boiler feed water is often abbreviated as BFW. So dissolved oxygen is in water. All water has oxygen, and it just depends on how much. And oxygen is actually very corrosive, and so if you're going to boil water to make steam, it's important first to remove the dissolved oxygen. So that's the purpose of a deaerator. And adding a little more complexity, if you have steam going into the deaerator, then you have the steam and oxygen going out to atmosphere. And often with deaerators, we talk about removing oxygen and non-condensables. And so the other non-condensable that's particularly problematic from a corrosion perspective is carbon dioxide, CO2, because that can do some nasty things in terms of lowering the pH when you make carboxylic acids or other acids. Okay, this is a diagram that I made, and it's once again simplified of a tray type deaerator, which is the kind of deaerator that I have experience with. And so with this type, you have the boiler feed water coming in the top section and stripping steam coming in the lower part of that top section, and you have trays. The stripping steam contacts the boiler feed water and removes the oxygen and other non-condensables, and it goes out a vent to atmosphere. And so with deaerators, you'll see a very recognizable steam plume out the top, and that's how you would recognize them, is a larger horizontal vessel with a smaller vertical vessel on top. So the larger horizontal vessel holds the boiler feed water. It's essentially kind of a surge capacity for your boiler feed water pump, which will then pump that deaerated boiler feed water to fired boilers for steam generation. Here's a picture from Wikipedia. So there's that larger horizontal section, which would hold the boiler feed water, and a smaller trade section up top. And then I'm more used to seeing the vent going directly vertical, not being too large, and having a steam plume directly above that smaller top section. This arrangement has a pipe out to the side, but you can still see the steam plume there. Okay, this is that same diagram with a few more details. So I just call it their spray valves. So when the boiler feed water enters, there's special, usually stainless steel valves that will cause some good dispersion to make some small droplets. And what that does is it allows the stripping steam to be more effective in terms of removing the oxygen and carbon dioxide. And the trays kind of serve a similar purpose of increasing that contact time, really some resonance time, and getting good contact between the steam and the small boiler feed water droplets. One other detail I put here was oxygen scavenger chemical injection. So whatever parts per billion of oxygen that you still haven't removed, and it's said that without any chemical, a deaerator should be able to achieve about 7 ppb of dissolved oxygen. So that's parts per billion. However, you can get even lower, or if the deaerator is not performing as it should, you can add oxygen scavenger to remove that, even to lower your DO even further. So the most popular that I'm aware of is sodium sulfite, and it's popular for a couple of reasons. It is inexpensive. It itself is water soluble, so you're able to inject it and kind of transport it easily. And also you're able to, the reaction product with oxygen is also water soluble. So here's a little reaction. So sodium sulfite is that Na2SO3, it's a salt, and it reacts with oxygen to make sodium sulfate. And the benefit here is you're able to remove that extremely corrosive oxygen from the water. You make this sodium sulfate, which itself is soluble, so you're not concerned about leaving behind any kind of potentially problematic or damaging products. And that is it. So those are the very basics of deaerators. There's obviously a lot more to learn, but overall, brief summary: deaerators remove dissolved oxygen. They help so that your boiler feed water is non-corrosive. Thanks.